Okay, it takes a little time to get organized and lined up because I've got to make sure that the video is in shot and everything like that. Okay, right, we can begin. Sitting gills, okay, and we're looking at conductors and insulators and its principles of electrotechnology, okay? Aims and objectives of this session: to understand why conductors and insulators are different, to be able to describe why different conductors and insulators are used. Okay. That's all revision, and that's a lot of work you've done already. Okay. If you haven't done it, get it done. Now, insulators. Um. Sorry, nope. Sorry, I was just looking at something else there on my table. Conductors. Repeat, conductors. In electrical engineering, a conductor is a piece of metal used to conduct electricity. There are a wide variety of conductors used in the electrical industry. There are also a wide variety of British standards that apply to cable types. Now, typical conductors include copper, aluminium, brass, silver, steel, cast iron, mercury, tin, bronze, and the list can go on. Okay. What makes a good conductor? Okay. What makes a good conductor? Metals make good conductors because they have at least one spare electron in the outer shell of the atom. So we have one spare electron in the outer shell of the atom, which allows this electron to move around under exertion. So it then can move from one place to another. So it pushes other electrons along. That single electron causes movement of mass others. Okay, basically. This is easily displaced, and the flow of electrons or electric charge can be set up. So one hitting the other moves it along, and that creates oscillation, okay, or movement of electrons within the electrical circuit. Here you have your orbiting electrons, here you have your shell, and here's your spare electron, okay. Number of protons in your nucleus is 29, an atom of copper, okay, and that refers to an atom of copper. Insulators. Now, an insulator is a material or object which contains no free electrons to permit the flow of electricity. When a voltage is placed across an insulator, no charge current flows. There are many materials that make good insulators. In the electrical industry, we have to include properties such as flexibility and lifespan, as well as the electrical insulating properties. The type of insulation used in electrical work are commonly impregnated paper insulation, elastometric, that's thermosetting, thermoplastic, mineral insulation. Okay, there are no perfect insulators. There has to be a compromise. Because why there is no perfect insulators? Because if you apply the correct voltage to an insulator, eventually it would break down. Here we are, impregnated paper insulation, okay? This type of cable has been in use since the turn of the century, 19th. Cable conductors are lapped with layers of thin paper tapes to the required thickness. This basic insulation can then be covered with lead or aluminium sheathing. Okay, and let me make sure you can see the different layers and their names given. Okay, okay, let's go with that. That's good. Okay. Now, paper insulated lead sheathed steel wire armored cable, PI, etc. stated here. This type of cable needs careful termination. Okay. Because it needs careful termination because one, you don't want it to be picking up damp. That will cause problems in itself. And here we have concentric aluminium cable or consac. This layer of bitumen containing a corrosion inhibitor. The aluminium sheathing over the cable is called concentric aluminium cable or consac. Okay, and this cable here, this is aluminium, so you can see that the core here is not stranded, it is solid core. Solid core because with regards to aluminium, aluminium would break. Okay, and you have to be careful with that kind of connection, and you can only get aluminium cables to a given size before it becomes basically unusable because of the potential to break at termination. Elastomeric or thermosetting insulation. Right. Sorry about that, excuse me. Types of elastomeric insulation include ethylene, propylene, rubber, EPR, and cross-linked polyethylene, XPLE. These are replacing paper insulated cables because they are easier to handle, install, and terminate. So elastomeric insulation is one that returns rapidly to its original dimension and shape after it has been deformed by stress. They can withstand high and low temperatures. They burn slowly but give off small amounts of poisonous gases. Polychloroprene, PCP, is used on farms as it is resistant to animals' waste product. It is also heat resistant, oil resistant, and flame retardant, HOFR. It is thicker and darker than PVC and doesn't tear as easily. Okay. Wave canal or aluminium waveform cables. And here we have our waveform cable. Okay. These cables use elastomeric insulation. The conductors are shaped aluminium insulated with XLPE. The cores are wrapped in a clear plastic tape and coated with a rubbery material, which acts as a bedding for the concentric protective earth and neutral conductor. The aluminium wires are not wound around the cable, but applied like a wave in motion. This allows for termination to take place without breaking any conductors. The cable is then surrounded by a PVC oversheath. Now the wave here, aluminium or copper wires, okay, is to support the main conductors to stop them from being stressed. So once they're supported along the whole rim, then the conductors, as they're aluminium, would tend to retain their shape and remain in position for a lot longer period by this method being applied. Now, joint, wave corner joint. Now, what we have here, we have three main neutral bunches. At these points here, the main cable is simply cut in two, right? You don't cut the cable itself, the main cable itself. These you then pick up by tapping into your main conductors and clamping on to them. Now, these guys would actually do this live, and they will have big gloves, electric rubber gloves on, and they would actually be cutting into these main cables while they're still alive, basically with thick rubber boots and standing on a rubber mat as well. So they are well insulated, but still I would not want to do their job. Okay, I'm telling you that for nothing now. This type of joint is usually made by supply companies, so this joint will be made by the supply company that will bring it to your houses directly, but quite possibly they'll take off one main cable and run it in, like say a cul-de-sac, then branch off single phase to each property in turn. Okay. Now, thermoplastic insulation. Types of thermoplastic insulation include PVC, polyvinyl chloride, and PE polyethylene. A thermoplastic material is permanently deformed when small amounts of stress are applied to it. PVC is the most commonly used thermosetting insulation. It is flexible and easily manufactured. It can only be installed at temperatures between 0 degrees and 70 degrees Celsius. If it goes too cold, the PVC will begin to crack, okay, and it will probably crumble away, leaving your conductor exposed. And if it goes above 70 degrees, it gets soft, and then again it begins to break away from the conductor, thereby exposing the possibility of exposed live conductors within, above or below these temperatures. It is used for distribution cables, usually in the form of PVC, SWA, PVC. It has a coating of PVC around its core, then a layer of steel wire armored with a final layer of PVC for additional protection. Okay. Now, mineral insulated copper conductor, MICC. Well, I know it as MICC, okay? So, but we'll stick with what's on the screen for the time being. Mineral insulated copper conductor. MIMS, mineral insulated metal sheath, okay? Okay. Cables generally consist of copper conductor insulated with compressed magnesium oxide, MgO. Now the MI sheath is made of copper and is unaffected by oil, water, and will withstand high temperature. Now it's very important that you do not get the magnesium oxide wet, because if you get the magnesium oxide wet, it would absorb all that moisture, and the thing is that it doesn't absorb it just for an inch or so, it absorbs it along the full core. Thereby you can imagine the length of time it would take to dry that MICC cable out. So never get your cables wet, MI60 cables, or that magnesium oxide, otherwise you will be there forever. You'll need to get a new reel of MI60. I call it MI60, okay, but you call it MIMS. The MI sheath is made of copper and is unaffected by oil, etc., etc. The cable comes with with a number of cores, conductors, and can range in size from 1 millimeter to 400 millimeters. The cable can be light duty 400 volts or heavy duty 750 volts. One of its benefits is its ability to withstand mechanical impact. You can hit it with a hammer, bam, 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 okay, and it will just go to shape, but it will not affect the conductors. It will still be functional. Okay. Let me just go in and make sure I get this. Okay, and pan back out. Okay. Let me just come down a little bit in case I am a little bit too high. And okay. Okay. Cable shapes. Cable conductors larger than 25 millimeters square are normally shaped. The shaping of the conductors gives an overall reduction of the diameter of the cable of nearly 10%. So here we have circular conductors and we have shaped conductors, okay? And when they say shape, they mean that they may put the cables will have, they won't be round, they might be slightly obscured or just off-centered, if you like to say, okay? Copper conductors are stranded once they become larger than 2.5 millimeter to allow for flexibility, but you do not strand aluminium, okay? Cable shapes, again, we still just look at cable shapes. You can see here when you look at the video that the shape of the cables matters. By shaping the cable, with aluminium conductors, it is normal to keep them as solid conductors until the side of the cables rise above 300 millimeters square. They then become stranded, okay? But you see that they can only become stranded over a certain size. The stranding of aluminium conductors allows for greater flexibility. However, the smallest size of aluminium conductor is 16 millimeters square, so it is not generally used. Okay. Okay. Hope you found this useful. Okay. Okay. I want to actually go back through this and cap on this if I can, but I won't. Let's see if it's worth it. Yes, I think I'd better do that. So I'm just recapping now, okay? Just want to obviously make sure that I've got it all in frame, as sometimes my camera might have a mind of its own and go its own way. Okay. Okay. Yeah. Okay, good. Okay, just recapping, making sure that I've got all the frames in view. Okay. Okay. And I'm happy at that. Let me just see if I can just see if I can get my what I had in mind up. Okay, I was looking at something else here. Okay, and here's some insulators that I thought that might be useful for you to have a look at as well. Okay, so that you're not only just looking at what we're doing, and let me see if I can bring up anything on armored cable, on heavy armored cable. 1 second, more. Nope. Okay. I'll try and see if I can get into any cabling systems. 1 second. No. Okay. Let's see if we've got any cabling system at all on it. Nope. What I was looking for was to show you the Cornell cabling system, but I hadn't come up here. Let's see what we got here. Nope. Okay. Well, you guys might be able to find it better than me anyway, as you all might have more time to research it than myself. Okay. 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 That's fine. Hope you find this useful and have a good day. Bye bye.